Okay, let's continue.
А что, может это тоже использовать, или это не особо?
Okay, first, what is two-step least squares? So I just recall our setup. We have y that is equal to beta times w plus, I forgot, I think plus, what was the error term? Nu. So this is regressor, this is error term, and my regressor is bad. Bad in the sense expected value of nu given my regressor is not 0. Or I will write in words expected value of error term given regressor is not 0. And suppose you are lucky. So you are lucky. You are born on the lucky star. And imagine you have found in, I don't know, maybe you ask your grandma, you know everything, what is the instrumental variable? maybe you go to root tracker and you say, download instrumental variable. Yeah? And so you are lucky and you have instrumental variable, I don't know. Maybe you just were walking with your dog and bounce $1 million and instrumental variable. Okay? So I don't know how to obtain it. But you are lucky and you have instrumental variable. Instrumental variable Z. And this instrumental variable has two properties. Expected value of error term given instrumental variable is we have discussed, yes, so recall, is 0. And expected value of your regressor given instrumental variable is
not equal to 0.
Is not equal to 0. So expected value of nu given z is 0. Expected value of w is not 0. Okay, this regressor, so this magic random variable, this instrumental variable or magic variable, has two strange properties. It is linked with regressor, but not linked with error term. And in this case, you may use two-step least squares. And two-step least squares basically says apply regression twice. So what is the two steps least squares receive? Two-step least squares. That says step 1. Step 1. So you have three variables. You have three variables: y, w, and z. Okay, so you have in your data set. You have y, y1, y2, yn. You have w, that is a bad regressor, a bad guy, and you have a good guy, zi, zi. So in your data set, you have three variables: dependent variable, bad regressor, and instrumental variable. Okay? The roles are the following. This is dependent variable, this is regressor, and this is instrumental variable. You have three variables in your data set. And two-step least squares says, first, make the best prediction of regressor using instrumental variable. This is possible with the rule. So this assumption says that you can predict regressor using instrumental variables. Okay? Instrumental variable contains some useful information about regressor. Yeah? Basically, this assumption says you can predict regressor using instrumental variables. Okay? So, step 1 says obtain the prediction W star using Z. How to do this? You just estimate ordinary regression. So you use ordinary least squares. W hat is some gamma hat. I will omit constant. So you can do the same thing with constant, but for the moment I will omit constant. So for the moment I will omit constant to just introduce the case, and then we will introduce the case with constant. W hat is gamma hat times Z. So just make a prediction using OLS. And step two, obtain the prediction y hat using not your bad variable, but predicted value of the bad variable using W hat. So use OLS y hat equals to beta hat times W hat. So you are not using your dependent variable and regressor simply. You replace your regressor with best prediction using instrumental variable, and you make on the second step, you regress dependent variable on the predicted regressor. So after step one, you will have 4 variables in your data set. You will have y, w, z, and predicted w. So after step one, you will have 4 variables, y, w, z, and predicted w. And you make simple regression, but you regress dependent variable on predicted regressor. So on the first step, you regress regressor on instrument, and on the second step, you regress dependent variable on predicted regressor. Okay? 2 steps. Yeah? That's fine? You can also obtain, in this simple case, you can obtain direct formula. It will happen, so final formula.
Bless you.
Проклятый коронавирус. Okay, so you will obtain, so if you do these 2 steps, you will obtain final formula for beta hat. It will not be the old one, yeah, because you do 2 steps. So the final formula, beta hat instrumental variables, will be sum of y times z divided by sum of of w. W times z. So it's a little bit different from our old friend. So just for comparison, beta hat OLS, if you would direct regression of y on w, you would obtain sum of y times w divided by sum of w squared. So this is not the same formula. This formula uses all 3 variables: dependent variable, instrument, and regressor. Okay? I will not prove this fact, that I will just use this formula. So if you do these 2 steps, you will obtain this formula. Okay? In the case of a constant present, how this formula would change? Who can guess? If you have a constant, how this formula would change? So for example, if you have y equal to beta 1 plus beta 2 times xy plus y, and you have so on the first step, you regress x on gamma 1 hat plus gamma 2 hat z. On the second step, you regress y on beta 1 hat plus beta 2 hat times this prediction from the step 1. Okay. And in this case, beta 2 hat IV will be just basically a copy of this formula. But what changes when we have a constant in regression?
Beta hat changes.
Yeah, how?
Changes
Okay,
by bar.
Y minus y bar
Yes.
times
Times z minus z bar divided by sum of z minus z
So I
bar
have
x squared.
x. Or I write double. Y minus x bar. Z minus z bar. So in every term I have removed average value. Okay. Case with constant. Okay, so that's a receive. I will, let's prove that it's okay. Let's prove that everything will be okay.
I have a question.
Yeah.
Could you explain this formula of IV for the intercept?
The formula beta hat for this term, for the first term, or for the beta hat 2, or beta hat 1?
Beta hat 2.
Beta hat 2. So if you follow these two steps, it can be proven that the result is like this. I will not prove it. I will not prove it because it will take us too far from our level of understanding. Just the basic idea.
Okay, so we just have to remember this formula.
That one. It's better to remember that one and just subtract average value each term. So you remember one formula.
But why is there, it's like W and there is like no W?
Okay, replace W here, so replace that's better.
Yes.
So just use I think that's better. That would be better. Just the same formula. So what is regressor? The bad regressor, let's call it W. You may call it X, you may call it W. Okay?
Я Настя.
Oh, nice to see you. So that's an exact copy of this formula. So just subtract. And it's important, roles are important, but not letters. What are the roles? This is bad regressor. So who is this one? This one is endogenous regressor. Who is this variable? Letters are not important, roles are important. Who is this Z? Because in other exercise it would be not Z, but P or R or S or L. So what is the role of this variable? That is
Instrument.
yeah, instrument. Okay, Y is dependent variable. So roles are important, not letters. And that is
Again.
instrument. Okay, once again. So roles are important, not letters. So in this case, this is dependent variable, this is instrument, this is, who is W?
Regress.
Bad regressor, endogenous regressor. And that, once again, is instrument. So important is the structure of the formula, not letters. Because you may say, let's the regressor be called Z, and that instrument be called X. So,
Просто так воспринимать проще, когда одни и те же буквы.
okay, so
Как
write
будто
the
что-то
same letters. So, but I think beta hat IV is just sum of dependent variable times instrument divided by sum of regressor times instrumental variable. I think it's better like this. Yeah. If you are speaking of the case without constant, so these are non-centered variable. If you speak about the case with constants, so you subtract average value in each term. Okay. Yeah. So let's check that this strange approach is valid in our case. You cannot always save the letters. So let's consider our example. In our example, who is an endogenous regressor? What was the notation for endogenous regressor? In our example, with Khachapuri's reported. Who is endogenous regressor? So it's important to keep track of roles, not of notations. Who was endogenous regressors? Who was dependent variable? Who was instrument? In our example with Khachapuri's.
Instrument was neighbor.
Yeah, not neighbor, but number of Khachapuri's reported by the neighbor. Okay, it was called.
W was called F.
Z.
No.
IV Z.
Instrumental variable was Z. It was the number of Khachapuri's eaten by person I as reported by her neighbor. Yeah. So this is the number of Khachapuri's eaten by a person, but reported not by that person, but by the neighbor. Okay. What is the dependent variable? What was the dependent variable in our example we are considering?
Y.
And what is the sense of this y?
Result.
Yeah, it's matrix, final result. Okay, of a person I. And what is the endogenous regressor?
That was reported or declared.
Yeah, it was, how it was called? How it was called?
X.
Star.
X star. So my point of view, Nastya, is that not letters but roles are important. So in every problem you have Z or X or X star, so it's important to understand the roles. There are three roles: dependent variable, bad regressor, and the magic instrument. So in our case, endogenous regressor, bad regressor is self-reported number of Khachapuri's eaten. So in our case, beta hat instrumental variable turns out to be, which formula we should apply? So we have three rows, just plug in the formula. I will write the base structure. We have ratio, sum in nominator, sum in denominator, something multiplied by something.
I think we should use the latest formula, but instead of W, we'll have X star. No?
So instead of, so we just plug in. So we have, what are the roles? Roles are important. Endogenous times instrument. Okay?
Yes.
So in denominator we have
X star
X star times
Z.
Z. Okay, in nominator we have
Denominator we have
Y
times Z again.
times Z. Okay? Yeah. So rows are important, not letters, because in another problem you will have another letter for endogenous regressor. I can't always keep the letters because there are too much problems and too few letters. I cannot always have the same Okay, let's check whether the magic works. So our algorithm says you just need to modify formula. You just need to use this formula. Okay, let's check that this works. Yeah? So basically we will check that this approach will give us in probability limit beta. Okay, so let's check whether this strange approach, so normal formula, beta OLS, says that we need to have sum of regressor times dependent variable divided by sum of regressor squared. Okay? Standard formula says we need to multiply regressor times dependent variable divided by sum of regressor squared. In this case, the formula changes. We have three roles: dependent variable, regressor, and instrument. Okay? So now let's check that everything will work. So we calculate probability limit of beta hat. So it's probability limit of sum of y times z divided by probability limit of sum xy star times z. We will divide by n. We will use the same trick. Okay? We will use the same trick as we have used before. So we divide by n in nominator and denominator, and we use weak law of large numbers. Let's say basically these will tend to the average value tends to expected value. Okay.
Mm-hmm.
So basically we use the same logic. The average sample mean tends to population mean, or another name for population mean is expected value. Sample mean tends to population mean, or tends to expected value. So in nominator I will have expected value of what?
Y times Z.
Y1 times
Z1.
times Z1. In denominator, I will have
x1 star
expected value of
x1 star
x1 star
multiplied by z1
times
z1.
Z1. Now let's plug in everything, and magic! It would be beta. So the problem is with this method is not to apply the formula. The problem with this method is to find such a magic variable. So my point of view that in most real life situations it's not possible. But modern econometrists argue with me. I'm a minority. So they say, yeah, you can find it's not a bad. In most cases, no. Maybe I'm not the right person to tell. Okay, let's check what is the expected value of y times z. Who remembers what is the formula for y1? It's beta times x1 plus what?
Epsilon.
Plus, I think u. Epsilon was, no, we should be careful because there are a lot of letters. No, as far as I remember, plus u1. Yeah.
It's the first one, right?
Yeah.
The first one.
Yes, U1.
u1. Multiplied, what is the formula for z1? In our example with Kuchipulis.
X plus delta.
Yeah, x1
Yes,
plus
x1 plus delta.
Mm-hmm.
Okay, so we have a beta expected value of x1 squared plus beta expected value of x1 times delta 1 plus expected value of u1 times x1 plus expected value of u1 times delta 1. And as far as you remember, x1 delta xi, delta I, ui, epsilon I are independent, and even more, expected value of delta I equals to expected value of ui equals to expected value of epsilon I equals to 0. So we have this information. So nominator would simplify to what? This value is greater than 0 because it's expected value of something non-negative. In this case, because these two random variables are independent, okay, it will expand into a product, expected value of x1 times expected value of delta 1. Expected value of delta 1 is 0, so this term will be 0. This term will be 0. The last term will be 0. Okay, it will be beta times expected value of x1 squared. Okay? Let's check denominator. What is the expected value of x1 star times z1? Expected value of x1, so what is self-reported number of Hachipuri's eta? It's x1 plus what?
Epsilon in this case.
Plus epsilon 1 times x1 plus delta 1. Once again, we have four terms.
And the only non-zero is the expected value of x1 squared.
Yeah.
In this case.
Yeah, we have four terms. It's expected value of x1 squared plus expected value of x1 epsilon 1 plus expected value of x1 delta 1 plus expected value of epsilon 1 delta 1. This is 0, this is 0, this is 0, this is expected value of x1 squared. And finally, this simplifies to beta times expected value of x1 squared divided by expected value of x1 squared.
Looks great.
Yeah, and that happens to be beta. Okay, so indeed, we have proven that in this simple case, this strange idea, that very strange idea, to use even, we have used a very strange indicator. We have used, so in our dream regression, we need y and the true number of Khachapuri-Seton. But we don't see true number of Khachapuri-Seton. Instead, so what is the message? So imagine that you like to make a regression of y on x. And this x is not observed. And what do we observe is you observe y, you observe x star, and you observe z. So you do not observe x directly. Okay? You have two. So what happens is a very strange thing. In our example, we have mastered to obtain a consistent estimator. So our beta hat instrumental variable tends to beta. And in our dream model, we just regress y on x. But that's not possible. It's only our dream to regress y on x and use ordinary least squares. It's not possible because we do not know the true number of Khachapuri-Seton. So we collect some information that is somehow related to x. We collect x star, we collect z. Okay? So x star is not x, z is not x. And using two noisy versions of x star is a noisy version of x. Yeah? X star is here. This is x star. Z is a noisy version of x. We have two noisy versions of x. And using two noisy versions of x, we obtain a consistent estimator in the regression of y on x. Okay? So these modern econometrists are happy because this is causal effect. If you eat one Khachapuri more, your econometrics grade will go up on average by beta. Okay. So let's solve some more problems. One more problem. Just just an example. Okay, yeah. Let's imagine that I would like to make something more interpretable. Oh, yeah. Let's imagine the following model. Let's imagine that y is beta 1 times x plus beta 2 times, I don't know, s plus u. In this case, so you every day, I is the number of day, you observe the number of, so the number of, this is number of wet people, so y is a number of wet persons, on day I. xi is a number, so amount, so this will be amount of rain, so I don't know, millimeters per day, I don't know. S is the number of umbrellas persons have with them. Number of umbrellas. Okay? So x influences, so beta is positive or negative, beta 2 is positive or negative, and the u is some random term, random error. Beta 1 is positive or negative, beta 2 is positive or negative. U is the number of wet persons during day I. X is the amount of rain during the same day. S is the number of umbrellas. So what is the influence of beta 1? What is the influence of beta 2? Just intuition.
I think by intuition, beta 2 should be negative.
Beta 2 is negative, and beta 1 is?
Should be positive.
Should be positive, yeah? Given, okay?
Mm-hmm.
Yeah, that's okay? And now imagine that you have no data on the rain. And all these, so this random, so these x and s are exogenous to you. So x, so the predicted error u given x and s is 0. So x and s are exogenous. The problem that you don't know the so the problem is have data, your data includes y, your data includes s, but you have no amount of rain, you have temperature. Your data, you have y, s, and maybe pressure. Maybe let's say pressure. Okay. So you have data on y, s, and pressure. Okay. Imagine that you have data on y, you have data on s, you have no data on x. Yeah? The case is clear. In your data set, if you would have y, x, and s, so according to our text, there are no problem. You just use ordinary regression. Okay? If you have data on y, x, and s, you have no problem. You just do ordinary regression. Okay? But your data set includes y for each day, s, and this is pressure, atmospheric pressure on day I. I would say, what about atmospheric pressure? And let's make some assumptions. Yeah, let's make some assumptions about to have an easy exercise. Let's make some assumptions. I don't know whether this is more realistic or not, but I think that's a little bit kind of true. But I don't know. I would say that using pressure, you cannot predict the number of umbrellas. So the number of umbrellas, and let's imagine that every variable is standardized. We have no beta 0, so to avoid working with constant. So everything is standardized. Everything is standardized. So expected value of S given pressure is 0. Expected value of X given pressure, but pressure is somehow related to amount of rain, so it's not 0. So imagine that this happens, and I give you data. I give you some data. So let's imagine that you have some data. The data is the following. Imagine that I have I say that you have 200 observations. The sum of ys, the sum of sy, the sum of yp, and I give you some numbers. Let's say minus 2, y pi is minus 3, and s pi is 5. Okay? I give you some data. So because you have data on y, s, and p, and my question in this problem, is the following. My question: obtain good estimator. Obtain good estimator of beta 2 hat. Obtain good estimator beta 2 hat. So estimate the influence of number of umbrellas on y. Okay? The problem is clear? Okay, what's the problem? The problem is that I do not observe x. Okay? Yeah? The problem is that I do not observe x. So, in my, if I would just do a simple regression, what would happen? So, let's imagine that I just, I don't know x. Let's just regress y on s. Yeah? I have no p in model. So, first idea, if I would, I may add more data. I may say that sum of si squared is, let's say, 6. I may add some more data. Okay, so if I would use a little bit dumb approach, so let's say dumb approach. Plain OLS. So I may say, I do not observe x, so let's call this part random term. Okay? I do not observe x. So from my point of view, this is dependent variable, this is regressor, I have y, I have regressor, I have some junk variable p, I have no p in regression. Yeah? So from my point of view, this is dumb, a little bit dumb, but anyway, I have y equals to beta 2s plus u plus beta 1 times xi. Okay? So this is my error term. Okay? Yeah. So I say I have no data on x. I have data on y, s, and some variable that is not present in my model p. So I just remove p from my data because there are no p in my model. The pressure seems to not influence the number of wet persons. Yeah. So if the pressure, atmospheric pressure is high, if it's low, given you have the same number, the same amount of rain, it seems to not influence the number of wet persons. Okay. Yeah. If x is given, if s is given, you know the number of persons with umbrellas, you know the amount of rain, so P is not influencing, so whether the pressure is high, whether the pressure is low, the amount of rain is the same, the number of umbrellas is the same, P does not enter the equation. So at first glance it seems, just remove P. You have no data on X, so just call these two terms error term, and so you have one dependent variable, one predictor. So it seems from first point of view that we need beta 2 like sum of, who remembers the plain OLS formula? Sum of what in nominator, in denominator? Nastya? You know everything?
Without intercept?
Yeah, without intercept. We have no intercept here.
So here it will be sum of x multiplied, sum of s multiplied by
Rules
y.
are important, not the letters, yeah? Sum of
S.
dependent variable times regressor, yeah? Divided by
Regressor squared.
regressor squared. So rules are important and not the notation. Okay, so in this case it's sum y times s divided by sum of s squared, and given my data set, I have sum of ys minus 2 divided by 6. Yeah? It's minus 1 over 3. Yeah? Given my data set. Okay? What is the problem with this dump approach? The problem is S is obviously correlated with X. So we have correlation. Our S is linked with error term. Regressor is linked with error term. Our our regressor is linked with our error term. Why? Because the greater is x, the greater is amount of rain, more persons with umbrella in the street. Okay? Yeah? So this approach is inconsistent. So beta 2 hat is inconsistent. So yeah, you can estimate it using OLS, but it's a bad estimator because expected value of error term given your regressor is not zero. This is called endogeneity. And so what is the cure? Yeah.
But like, why are number of umbrellas correlated with amount of rain?
Imagine that you have no rain. How many umbrellas would you expect?
So like two dependent variables that
The
are
number of
correlated.
Depends.
It's like multi-correlated.
It's not multicollinearity.
So
You have no
it's
second
clouds,
regressor
like-
at all.
We
It's not
will-
multiple.
we will
No, I
have
mean
some-
from here it's two regressors x.
But
and
that's okay.
s.
It's not a perfect dependency.
So it's not multi-collinearity.
It may be weak multicollinearity,
Mhm.
but we don't care. Multicollinearity is not a very extreme problem unless it's too strong. Yeah, there may be a link between these two variables. Yes, it's called a multicollinearity, but don't be afraid of it.
Mhm.
That's okay. Yeah, when x is small, you expect small number of umbrellas. When the rain is very hard, you expect almost everyone with umbrellas. Yeah. But the dependency may be not linear. If the rain is beyond certain intensity, everyone is with umbrellas. So it may be not a perfect linear relationship, so the multicollinearity is not exact. Okay, so we have an endogeneity problem or weak multicollinearity problem for this regression, but basically, okay. So, but in our case, we have a savior, this P that seems we don't need P in our model. There are no P. There are no P in our model. There is X and S. And this P will serve us as a savior. Why? It's a savior. Because if we look at this P, this variable is not correlated with... sorry. I'm mistakes about assumptions. I need... what do I need about this P? I need... that's the P is a bad... I need one more. So it's a bad instrument. I need another assumption. I need something what is correlated with umbrellas. Sorry. So because I need instrument. So what are the properties of instrument? So P is not a good instrument. The good instrument should be correlated with whom and not correlated with whom. The good instrument should be correlated with. But look at what we have written. Look, the good instrument should be correlated with...
Прогноз погоды можно.
No. Just the definition. The good instrument should be correlated with...
Why?
Not y. With roles.
S.
With regressor.
Regressor, yes.
Let's say roles and not... Let's use roles and not letters.
With the regressor.
The good instrument should be correlated with regressor and not correlated with
X.
not letters, roles.
Instrument.
Good instrument should be correlated with
Error term not correlated with error term.
regressor and not correlated with error term. So could you imagine a random variable that is correlated with the number of umbrellas but not correlated with weather? Okay? Could you imagine imagine. That's hard to imagine. So that's why. So P is a bad instrument because P, we need a variable, very strange variable that is correlated with a number of umbrellas, but not correlated with rain. You can imagine, for example, no, it will be correlated with umbrellas. So let's imagine a random variable like taxes on China goods. Yeah. Yeah. Let's imagine a variable taxes on China goods. So let's imagine, but they do not vary much day by day. What else can we imagine?
That is correlated with.
I mean something that is correlated with a number of rows, but not with weather. I imagine that you have a. So imagine that you have a variable taxes. So and taxes were 10, 10, 10, 10, 10. But after some changes, you have big taxes on imported goods. Let's imagine you have sanctions, and these sanctions, they have nothing to do with weather. But these sanctions, they influence the number of umbrellas just people have. Okay?
Umbrella tax.
Yeah, umbrella tax. Yeah, you have umbrella tax. Have umbrella tax. You have a variable umbrella tax. That is tax. Umbrella tax. This umbrella tax, it is obviously correlated with the number of umbrellas. Imagine that when you go out with umbrella, you need to pay to the local government 100 rubles. Okay? Yeah? Imagine umbrella tax. But this umbrella tax has nothing to do with weather. Okay? So on a shiny day, if you go out with umbrella, you pay. On rainy day, if you go out with umbrella, you pay. And this tax, so you have expected value of S given umbrella tax is not 0, but this tax has 0 correlation with weather. Okay? So imagine such a variable. In this case, P is not a good instrument, but T is an instrument. Okay? Yeah? Because our T is correlated. So we need instrument. Instrument should have no correlation with noise, but should have correlation with number of umbrellas. Mm-hmm. So in this case, we need to search for some kind of umbrella text that is not related to weather. So my point of view is that in real life it's very hard to find such a variable. You need not only to find it, but to collect data on it. So in real life it's extremely hard to find it. But imagine that you have data on this umbrella text, and you have sum of, what do we need? Sum of y times umbrella text is -5. Sum of t times s is, let's say, 3. And what would be your good estimator? So we see that P is a bad instrument. T is a good instrument, because what properties are needed from an instrument? Instrument should be correlated with regressor, but should not be correlated with error term. Okay? Our umbrellas text is correlated with a number of umbrellas, but is not correlated with weather. We have just sanctions because of some political conflicts, and that has nothing to do with weather. Okay? Yeah? So sometimes it happens, but not so often, because in every modern work on econometrics you have some, we have found a magic instrumental variable. So in our case, beta 2 hat instrumental variables, it's better to speak always in terms of roles, not in terms of variable names. So what should we have in nominator and denominator? So good, consistent estimator. Good, consistent estimator. So what we should have in numerator, in denominator.
Regressor multiplied by dependent
Where?
up.
No, not regressor.
Oh no, not regressor. The
Dependent.
Z.
Who is that? It's better to speak in terms of roles.
By instrument. Dependent multiplied by instrument.
Who?
Dependent multiplied by
dependent
instrument.
multiplied by instrument. And in denominator, it's better to speak in terms of roles.
Endogenous regressor multiplied
Regressor
by instrument.
Multiplied by instrument. Okay, let's move on to our particular case. Because there are a lot of letters, we just need to speak in terms of roles, not in terms of letters. Who is dependent variable? In our case, y. What is instrument? P or T?
Should be T.
Yeah, it should be T, because we need a variable that is correlated with the number of umbrellas, but not correlated with the amount of rain. Okay? And Texas seems to be not correlated with the amount of rains, but correlated with the amount of number of umbrellas. Okay? So in our case, we use sum of yt divided by, who is regressor in our model?
Bad regressor.
Yeah, bad regressor.
X.
No, we have no x. X is not regressor. We have no x. Our bad regressor that is correlated with error term is S. S
Yes.
times
P.
instrument. No, instrument. Who is instrument?
T.
T.
Only T.
Yeah. Once again, what are the properties of instrument? Instrument should be correlated with the bad regressor which enters our model. In our model we have S. We have data on S. We have no data on X. X cannot be regressor in our model. So, and this is minus 5 divided by 3. Oof. So, I will try to post some exercises. But basically, we have the situation when regressor is correlated with error term. We cannot do just simple regression because it will provide us inconsistent estimator, too low or too high, we don't know in general. And in this case, sometimes magic happens. Sometimes you can find a variable that is correlated with regressor and non-correlated with error term. Okay? Regressor is a variable present in model. The variable that is not present in model is a missing variable that's not a regressor. So X is a regressor in our dream equation. If we would have X, then it would be a regressor. But it's only a dream model. We cannot estimate this dream model because we have no data on X. The actual model we work is this one. Y is dependent variable, S is a regressor but a bad regressor. And this is error term, so we need an instrument in new variables that is correlated with S but not correlated with the error term. Okay? X is indeed, you may call it regressor, but in a dream equation. Yeah, if you would have X and S, just regress Y on X and S and be happy. That's all. I will try to provide an exercise. Maybe there is an exercise in past exams. But basically, yeah, you need to find a magic variable that is correlated with bad regressor and then correlated with error term. Okay? That's all for today. Next time we will work with panel data and we will use computers.